Hello, everyone. My name is Konrad Kamiński. I work for Allegro, which is the largest Polish e-commerce company. And today we're going to see how we can write asynchronous applications with Kotlin Coroutines and with Spring. But before we start, I want you to know that I have some gifts for you. So I come from Poland, and Poland and Kotlin have a lot of things in common. So for example, has any one of you actually tried to access the Kotlin.com webpage? Not, OK. So if you decide to, you'll actually not find any information about the Kotlin language, because Kotlin.com is an official webpage of the administrative district in Poland. And in that administrative district, there is a village called Kotlin. And in that village, there is a company which produces ketchup. And I happen to have a few bottles of this ketchup. So it's something like here. So I have different flavors, like a mild one, a hot one. And this one's actually extra hot. It says, like, born in hell. So if you want, just come after the talk, and you can grab one. Actually, I just realized that's like a very neat way to keep the audience, during the whole talk. OK, so let's get to business. We've got little time, and we've got a lot of things to do. And so here we have a simple web method. A simple web method with simple, straightforward code. The method first validates if a user is a valid user, so that we can return some data. And then it gets this data from some database. And let's suppose that our user validation service is a component which accesses an external endpoint. So it goes over a network to check if that user is actually a valid user. And the getProducts method of the product service actually accesses some database. So it also goes over a network to get this data. And this is a very nice code because you can read it quite quickly. It's maintainable. And this is the kind of code especially I like, because I can see what happens immediately. But the problem with this kind of code, or the kind of applications that we write with this code, is that they are not scalable. So by not scalable, I mean that these methods are synchronous methods. So we have to wait for the isValidUser method to finish before we proceed further. And if it goes over a network, then it means that our thread which executes this method is blocked. So essentially, it's doing nothing. And if you have a number of these threads, if, for example, this endpoint is accessed by many users or by many systems concurrently, then for each request, we have a thread. So we can have like thousands or 10,000 of threads which are blocked waiting for something, like for a database server response. So the solution to this problem is to use some form of asynchronous programming. And we have a number of solutions here. So we have callbacks. So if you happen to do something in JavaScript, you know that there are callbacks there. And the problem with callbacks is that the code you write is really not that readable. You get this callback hell problem. The other solution is to have some kind of promise object. So we have completely future in Java. With reactive APIs, we have those reactive types. But then we have to change the style in which we write our applications. Because now we have to decompose our application to write in functional style, so we don't get this nice picture of sequential code. Now, in Kotlin 1.1, there's a new feature called Coroutines. So yesterday, Roman Elizarov talked about it. And it allows us to write this kind of sequential code, but at the same time, this code is actually asynchronous. So how is it possible, and how can we leverage that to write these kinds of applications with Spring? So first, in order to actually understand why Spring does not work with coroutines right now, we have to understand what kind of problems coroutines make and how can we solve them. So here you have a simple suspending function. So I will actually use the term coroutine and suspending function quite interchangeably. Technically, they are different things, but because coroutines are essentially instances of the code that you can see here. But what we write actually is suspending functions or suspending lambdas. So what we see here is a suspending function with one parameter, which returns a result of type int. It is very simple. It just waits for 100 milliseconds and then returns some constant value. So below you can see the code that is, it's not actually what you get from the Kotlin compiler, but it shows what problems we might have if we want to use it with Spring. So let's first look at the signature of the method. So now we have the additional parameter of type continuation, and our function actually returns an any value. So why is it like that? With suspending functions, there is this special contract for these functions. So if a suspending function does not suspend its execution, then the value is returned normally. I mean, the return type is any, so essentially we can return anything. But if it suspends, then it returns the special constant value, coroutine suspended. And the true value will be returned via this continuation parameter. It's sort of like a callback. So let's try to analyze this function so that we can understand how it actually works. So first, we call the delay function. The delay function is like the standard function in the Kotlin X library. It's a suspending function. So it's sort of like a sleep method of thread, but it doesn't actually block the thread. It will wait for the specified time. So it will suspend the execution for the specified time. So since it's a suspending function, we have to provide a callback parameter of the continuation type. So we'll provide one here. So if our delay function does not suspend, it just simply returns, so delay actually returns a unit. But we check if it doesn't return this special value, this coroutine suspended. If it doesn't, it means it doesn't suspend the execution. So we can just return this 5, 6, 7, 8 value that we want. But if the delay function suspends its execution, it returns this marker object, coroutine suspended. And then our method should also return this value to indicate that to the caller of our suspending function that we also suspend it. Now, when the delay function finishes its execution, it will call one of the two methods on the continuation object that we passed to it. So it can call resume, and it will call it when there is no exception thrown from delay. It will call resume, and then we will call resume on the callback that was passed to us. So essentially, the object, the continuation object that we created here acts like sort of like a proxy. And with the resume with exception is the method that is called when the delay function throws an exception. So we also throw the same exception. So this is quite simple. Now, the most important thing that we have to remember is that a suspending function suspends its execution, but doesn't mean that the thread is blocked, because it's not blocked. And we have to remember that the signature of the method is different from the one that we declare. So what we want to have is this kind of web method, a web method which is a suspending function, so that we could use suspending functions inside our method, because suspending functions can only be called from within another suspending function or a suspending lambda. So how can we do that? So the problem is that when Spring wants to invoke a web method, it looks at the parameters of this web method and tries to provide instances of the parameters. So for example, here we have a parameter which is annotated with path variable. And there is a special handler for such parameters in Spring. In fact, there's like a list of handlers which handle different combinations, different kinds of annotations, etc. But there is no such handler for continuation. So when Spring will see that, looking at the signature of this method, that there is actually a parameter of type continuation, it won't know what to do. So we have to provide a handler for such a parameter on our own. So how can you do that? This is actually the code that will do that. So let's try to see the details of it. So first, the handler must be of type handler method argument resolver. This is the type defined in Spring framework. Then we have to tell Spring that our handler supports suspending functions and essentially this parameter of type continuation. And then we have to somehow provide an instance of this parameter. So we'll provide one. And Spring already has support for asynchronous methods. There's a number of different ways you can write asynchronous code with Spring. And one of them is that our method, our web method, can return a deferred result type of value. So a deferred result, it's very similar conceptually to continuation. So it also has two methods where you call them to indicate that you have a result available, or that the asynchronous method returned throws an exception. So what we can do is we can somehow trick Spring into thinking that our suspending function is actually a regular function which returns the deferred result value. So this is why here we have our continuation object, which contains this deferred result. And when the methods on the continuation object are called, we will just call the counterpart methods on the deferred result. So this is why when the resume method is called on the continuation object, we call the set result. With resume with exception, we'll call set error result. And there is one more thing we have to do. So we have this deferred result, but we have to store it somehow, somewhere, so that when our suspending function finishes its execution and the suspending function suspends, then we should return this deferred result type. So how can you do that? So for parameters, we have these handlers, this list of handlers which Spring has. And the same goes for return values. There is also a list of handlers for return values. So if you want to have a handler for our return value, which can be this coroutine suspended object, we have to define async handler method return value handler, a very long name. What we can do here is first we indicate if our method is actually a asynchronous method. And it is asynchronous if it returns this special value, this coroutine suspended. So we also have to tell Spring that we support only suspending functions. And now Spring iterates over all of these handlers. And when it finds one which is suitable, so if it finds our handler, it will call the handle return value method. And it will be called only in the case when the method actually suspends. Because if it doesn't suspend, it will return like a regular object, like a regular value, and the regular handlers will handle this value. So what we do here is we actually take out this deferred result that we remembered in the previous handler, and we'll delegate the handling of this deferred result to a deferred result handler, which is originally available in Spring. So that way, with these two handlers, we'll trick Spring into thinking that our method is asynchronous. Now, I'm showing you this because this is something that has to be done in many areas in Spring, because and Spring actually has this nice extension mechanisms in those areas. Well, sometimes it doesn't. We have to do some things which are a bit hackish, but this is one of the ways. And the other thing I wanted to tell you is you don't have to write this kind of code yourself. So there is this spring-kotlin-coroutine library available. It's not an official part of Spring framework, at least not yet. But you can use it. It's open source. It's available on GitHub. And today, we're going to see a few examples of how we can use it So we're going to actually create an application with the endpoint, which looks almost exactly as the one that we've seen on the first slide. But our application will be an asynchronous application written with Kotlin Coroutines, which will use non-blocking IO. So essentially, we'll have a scalable application which uses and which doesn't use a lot of resources, and at the same time, we will have this nice sequential code that we like. So let's see some code. One more thing, this library is available on GitHub on this address. So if anyone is interested, that there is some documentation there, the source code. OK. You see it? OK. So first, let's try to just create a simple endpoint, which is a suspending function. So in order for the suspending functions to work, we'll actually have to add the enable coroutine annotation on our configuration class. And we're going to create a REST controller. Let's name it simple. It's available under simple. And let's call our method simple. We'll return an int. We're going to log something so that we can see what happens and essentially what threads are being used, because this is quite important. So let's log in simple. 1, 2, 3, 4. OK. So we're going to run our application. OK, and let's scroll to see the response. OK, so we got the response. Now, OK, I forgot about making it suspend. OK, once more. OK, so now it works. But you know, our suspending function does not suspend at all here. It's like a regular function. So let's make it suspend. So let's use this delay function that we've seen for 1 millisecond. Let's also put something in the log output after delay. And now let's see what happens. So we see this marker here. So idea is this nice ID which will tell us where our suspending function can suspend. And this is the special marker here. OK, so let's try this one once more. So we can see here that it actually works. But one thing which is quite interesting is that the first thing which is in the log output was actually done in this thread. And the last one is this thread. So it's a different thread. And this is actually something we should expect, because suspending functions, they suspend, they do not block thread. So the web container thread that was executing our simple function, it just finished its execution. And then the delay function used another thread to call the resume method on our callback. So this is quite a simple example. Let's try to go to the application, which is a bit more complicated. So here we have our getProducts endpoint that we've seen on the slide. So let's make it suspend as well. And let's enable coroutine. But still it is a regular function right now. Not regular, but it doesn't suspend here. So we have to change our isValid and getProductList methods so that they are all also suspending. But before that, let's add some logging statements so that we can observe what threads are being used in these methods. So let's call it before valid and after valid. And Now we can make our isValid method suspending, but that won't change much also. So we have to find a way to make it execute on a different thread. So essentially, we have this kind of architecture of applications where we have different thread pools for different functionalities, where threads can be blocked, but there's a limited number of those threads, so we don't waste so much resources. So we can have an architecture where our web framework will use one thread pool, our service, which accesses this external endpoint, will use another thread pool, and the database will also use another thread pool. So the processing of our request will go from one thread pool to the other. And by scaling the number of threads, we can scale our application. And this is actually needed because these APIs that we're using here, they use blocking IO. So there's really no way to overcome that problem that it will at some point block. So all we can do is just limit those number of threads that are blocked waiting on a socket, for example, for the response from the server. So we can use coroutine context for that. So a coroutine context is something which is assigned to every coroutine, and it can play several roles. And one of them is that a coroutine context can be a coroutine dispatcher. So essentially, it can contain a logic which says what kind of thread is being used to execute a coroutine. And so we can have like a custom thread pool where we will execute, for example, our isValid method or whatever is inside that. And there is a couple of different things that we can do to use a custom coroutine context, a custom thread pool. But so one thing we can do is we can use a run method. Let's use run a common pool. This is the method from the KotlinX library. So here we specify that it will use a common pool. This is the coroutine context that's quite similar to fork join pool. And so now when we run our application, we're going to see that we're not going to see because we haven't added the logging statements here. So let's add some before. OK. So now we should see that the threads that are being used for the getFromObject methods are from the common pool. OK, we don't see it. The question is why. This is always a problem with live coding. We're not invoking the demo. OK, that's the old application, sorry. OK, let's try this one. OK, and the endpoint address is users. I will use Konrad because the database that I use actually has some products which are assigned to Konrad. OK, so we get some result. And here we can see that, that the isValid method is called, and it uses the threads from the common pool coroutine context. But common pool is a context which is essentially we can use it, but we wanted to have a separate one, and the common pool is usually used by many different things. So we're going to create a custom coroutine context and use it. But every time we use a coroutine context, if we wanted to do it this way, we would have to invoke this run method. So it's quite inconvenient. So this is why in the spring-kotlin-coroutine library, you can put the coroutine annotation on your method and specify what coroutine context is supposed to be used. So for common pool, we can specify a common pool. But we wanted to have a custom one. So let's create a custom coroutine context. Let's name it external service context. OK. So we'll use a function which is also available in the Kotlin X library, which allows you to create a coroutine context with some thread pool, where you can specify the number of threads, and you can also specify how the threads are named. So we'll create one which will use the external. The threads will be named like external 1, external 2, etc. Really? Service here. Oh, OK. Actually, here it doesn't matter. It would matter if it was here, but yeah, so thanks for that. OK, so let's go to is valid. OK, so now we can get rid of this one. And we have to add return here. And we should get this behavior where our isValid method now uses the thread pool and the threads from this thread pool, which are the threads are named external 1, etc. So let's try to access our endpoint. So it works, and we can see that the isValid method uses the threads from this thread pool. And actually, you can use this annotation, and you can put it also on a class. And this way, all the methods which are defined in this class will use that coroutine context. And we can actually do more. We can actually create an annotation class, especially for the combination of these two annotations, like let's name it external service. Yeah, so it's sort of like a meta annotation. And now, whenever we want to create a component which accesses an external endpoint, and we want to have a shared thread pool for all those components, we can just use this annotation, and it should work. So let's try it. Yeah. So we also have a Mongo database here. So we can have a separate thread pool for a Mongo database as well. So here, our product service uses the repository. The repository is the Mongo repository. It uses Spring Data, quite straightforward solution. So let's make this function suspending. Let's make it use a special coroutine context. Let's call it Mongo context. OK. Mongo. Let's call it Mongo. And yeah, so let's add some logging here also so that we can see what threads are being used. OK, before. OK, so that should work. So let's restart our application and see what threads are being used. OK. So now we can see that the getProductList method uses the thread pool, the dedicated thread pool for Mongo. So we can create applications this way. And this is actually something that we have to do if we have blocking IO. But Spring 5, which came like a month ago or so, it uses non-blocking IO in many places. So it provides reactive APIs in those different areas. So for example, we have now a second web framework in Spring, which is called Flux, where you can write applications which use non-blocking IO, but the API actually uses reactive types. And we used REST template here to access the external endpoint. And Spring 5 has web client, which also has the reactive API, and it uses non-blocking IO. And for Mongo, we have reactive Mongo repository now, which uses non-blocking IO. So it would be really great if we could somehow use this implementation in coroutines. And this is actually, right now, it's possible with this spring-kotlin-coroutine library. So let's try to change our application so that it uses non-blocking IO. So let's try with the web framework. So right now, our application uses the WebMVC web framework. But in order for it to actually use the web Flux, we only have to change a dependency. So we have the dependency to WebMVC here, and we'll change it to web Flux. And here, instead of web, it's also web Flux. Yeah, so let's try to run it again. OK. OK. So it's not clearly visible that it uses non-blocking IO. So the most visible thing is that now we use Netty web server. And this is because WebFlux actually supports a number of different HTTP servers. They don't have to use servlet API. They don't have to provide servlet APIs. And Netty is one of them. It's actually the default one. But if you want to use Tomcat or Jetty or Undertow, then there's an option just to change the dependency, so to tell Spring that you want to use a different HTTP server. But Netty, it's quite nice, it's quite fast, and it provides a reactive API out of the box, and this is actually used by the Spring Web Flux. So now we have non-blocking IO in our web layer, in our web framework. So let's try to change our application so that it uses non-blocking IO also in other parts. So first, let's try to change the isValid method. So we're using REST template here, and we can't use it because REST template essentially has blocking API. So it has to use blocking IO. Now, in Spring 5, there is web client, which we can use. It's quite simple to use, so we'll just rewrite this code. So we'll get the response, and this is the way to do it with reactive APIs. Connect it to mono, but so now we'll have the what's the type of it? We'll have a mono of string, and this is not something we want. The mono is like a reactive type in the project reactor library. So there are two options here. So one is there are these bridge methods defined in the Kotlin X Spring Reactor, I think, library it's called, where you can just call some extension method on this mono and have a coroutine here. So await first will actually await for the first result in that mono. So a mono is like a stream of 0 or 1 values. So probably what you should do here is just call await first or default with null, so that if the endpoint does not return anything, we'll just get null. And then we want a Boolean here, so let's make it Boolean, something like that. But that's a bit clumsy. We have to call body to mono, which is like, it's not in a coroutine world. And we have to call these extension functions all the time. So that's why we can use a coroutine web client, which has a very similar API. So if you know web client, you can easily use coroutine web client. We don't have body to mono because we don't have mono, but we have just body. So we can get rid of this one. And we also have to add this, because the body method can return a null value. So body to mono returns a stream of 0 and 1 values. So in coroutine world, it means that it can be a null value or some value. So that's probably almost everything we have to do. Let's get return. Yeah, and now we can actually get rid of this annotation, because the web client will use the thread pool from the WebFlux web framework. And we can actually get rid of the REST template as well. OK. So what now we should have is that we will have a web layer which uses Nonblocking IO, and we'll have the component which accesses an external endpoint which uses Nonblocking IO. So it works here, and we can see that the isValid method uses threads from the web Flux web framework. So we have 2 out of 3. So let's go to Mongo. So we used here the Mongo repository, which has this blocking method. Now, there is this project called DataMongo Reactive, I think, in which you can use this Reactive Mongo repository, where instead of list, you can specify that you want Flux. So a Flux is like this reactive type for an possibly infinite stream of values. But with coroutines, we can simply make it a coroutine Mongo repository. And we'll mark this function as suspending function. So our product service, we can now just get rid of this annotation here. And that's all there is to do. So, okay, right. So there's one more thing we have to do, because as I told you, this application, it first fills in the database so that we see some results, and it uses the same repository as our product service. So we have to change the event listener that we have here to suspending. It actually shows you one more feature of the spring-kotlin-coroutine library. So we can now have event listeners, which are suspending functions, and we also can publish events using the special coroutine application event publisher, which has the suspending functions for publishing events. So if you want to have an event bus where we publish something, and we have event listeners for those events which are on the event bus, and on both sides we use suspending functions, then we can have this asynchronicity all the way. So this is why I had to change it, but it should work. Yeah, so let's try to run it again. Okay, so in order to actually use coroutine Mongo repositories, we have to specify that we want to use them with enable coroutine Mongo repositories. Okay. Right. Okay, so it worked. So the Mongo, the repository, the coroutine Mongo repository, actually the implementation, uses these threads which are named like these. So now we have an application which is scalable, which is this Nonblocking IO, which is this Kotlin coroutines, which is asynchronous. So this is actually something that we wanted from the beginning. So one of the things that I wanted to show you here is that you can easily convert your existing application into the one which uses coroutines in Spring, and you don't have to change the way you write your code. Because with, for example, with Reactive Java, with Rx Java, or with Spring 5, you have to change your code so that it's more functional. Here you don't have to do it. And what's more, you can actually introduce coroutines in your applications gradually. So you can only do it on a web layer. And you can stay with blocking IO. Actually, this the last version of this library uses Spring 5, but the previous one uses Spring 4. So if you're on Spring 4, then you can use it as well. I mean, you won't get these nice non-blocking IO components because there's no support for them in Spring 4. But you can easily then move to Spring 5 by just changing the dependencies. So if you start a new application, you can try using it, and you will have this whole bunch of features from the beginning. If you have already some application, then you can just gradually introduce new features with coroutines. So let's get back to the slides. Yep, I talked about that. So actually, this library, it contains some more features which I haven't talked about. So for example, there's support for cacheable annotation, because normally the Spring will not support coroutines with the cacheable annotation, since the suspending function has this additional parameter and this different semantics of execution. But with this library, it's quite easy to do. We can use event listeners and we can publish events with suspending functions. We can use scheduler, so we can annotate our suspending functions with this scheduled annotation. We have something which is called functional style route definitions. This is something which is new. It's a part of web Flux in Spring 5, where instead of creating web endpoints as components with those annotations like REST controller or get mapping, post mapping, etc., you define your application or your web endpoints in a functional style. There's actually a talk by Sebastian Deleuze, I think in 2 hours or so, where I think he's gonna present some more details about it. So I suggest you to go and see it. And as I told you, you can find more things at this address. There is some documentation. It's a little bit scarce, at least for the new stuff, for Spring 5. For the old stuff, I think it's pretty good, at least as an introduction. And as I told you, this is not the official part of Spring yet. So we have to wait probably a few months or so to make it an official part of Spring, I hope, at least. OK, so that's all from me for today. If you have any questions, then just shoot. OK?
First of all, thank you. I was wondering if you have any support for transactional boundaries.
Yeah, so the question was about if there is support for transactional boundaries. So Spring 5, when it introduced reactive APIs, so it intentionally does not support reactive APIs for SQL databases, essentially for transactions. And this is mostly because of the different threading model. So with normal transactions, you have a single transaction and a single thread. The thread doesn't change. So this is why this library actually doesn't support that as well. I mean, in the future, if the reactive APIs support it, then it can support it as well.
So then a follow-up. So things like MDC and like Brave or Dapper, that won't be supported either?
No. So things which use thread local, essentially, will not work here. There is this coroutine context here. So a coroutine context is sort of similar to thread local, and you can use it for some things. So for example, I've shown you the coroutine annotation. There are actually some additional attributes where you can, for example, specify a name for a coroutine, and it will be visible in the name of the thread, I think. So you can use it for such things like thread locals. But essentially, it's a different threading model, so you will not get things that you just said. OK, any other questions? You're waiting for the catch-up. OK, so thank you very much.